I love you too.
That has got to be the sneakiest tornado ever. Welcome back to Atomic Twister Part 2, where we see their emergency response. Our fearless leader leaves the control room, goes through the turbine building in extreme wind, just goes out the door to try to find a signal, abandoning her crew during an event. Also, you saw in that picture, they said they had a reactor number. That implies there's more than one reactor at this place, but it might not be operational yet. Okay. So they lost a transformer. Time to enter the loss of power procedure to see what exactly they lost and to get power restored using backup systems. They should still be fine at this point.
Where's the backup?
The backup system should be initiating. Why are we browning out, Gail? Where's the backup?
I don't know. Only one of the backup generators is working.
Generator A is right next to the transformer.
They lost the backup too, and they put the backup right next to the normal? What clown college dropout thought that was a good idea? A robust engineering design consists of three things. 1. Backup systems, redundant systems. 2. Diverse systems, so that means different types of power sources. So off-site power and having them diesel-backed. Sure. But 3. Physical separation from each other to ensure that this sort of thing doesn't happen. The nuclear plant that I worked at actually had 3 complete trains of safety equipment that had everything you need to safely shut down the reactor. And each one of those had backups. And we had backups for those backups as well. So they were also separated between massive walls of concrete, and they were physically located away from each other. Wow. At this point, total loss of power to any one source of one train of your safe shutdown equipment would warrant an entry to the emergency plan at the level 1, unusual.
Okay, we need to find a way to reduce power consumption.
Only reason why you'd want to do that is if you really lost everything. They said their instruments were off too. That is pretty crazy. Okay. They never explain what reactor type they have. In the United States, 2/3 are pressurized water reactors and 1/3 are boiling water reactors. Let's just assume it's a pressurized or PWR. Nobody's talking about the reactor this whole time. That's one of the first things you check when you lose power. If they really did lose all of off-site power like they said they did, which doesn't make any sense because it's just one transformer, the reactor would have automatically stripped, which is an emergency shutdown, due to the loss of forced circulation from the reactor coolant pumps. The reactor operators would need to perform immediate actions to ensure the reactor is safely tripped and the turbine is offline. Then they will go to their cool-down procedures to cool down the plant using natural circulation by dumping steam. And that will put everything in a safe condition, even without power. One other thing I've noticed is instruments are DC powered. So they should be able to save the day even without AC power at all on the entire site. There is a specific emergency procedure that directs this operation, and then load shedding. Total loss of power. Yes, you want to shed loads, but again, the core is your priority. So evidently we're dealing with a bad design and bad operators.
NRC, Corinne. There's a procedure for this, I'm sure.
The procedure is to call the NRC and evacuate all unnecessary personnel. On a Saturday with the skeleton crew, that's irrelevant.
Talking about procedures, so they're talking about emergency plan. They mentioned nothing about protecting the core, though. Also, the NRC, again, is the regulating body. Yes, you'll contact them eventually, but that's by no means the first step in an emergency plan either. You see all those flashing lights in the background? Those are the annunciators, the alarm panels. If you read those, acknowledge them to get them to stop flashing, and you can see what you've exactly lost. That is very helpful during a loss of power event to see what you've lost. So evidently they weren't being accurate when they said they lost all instrumentation, because those things wouldn't be working, and I'm still not convinced they actually lost everything. They need to sit down and methodically look at their indications.
County, Tennessee. I'm the active shift supervisor, and I am declaring a stage 1 alert.
So the shift supervisor does perform emergency plan declarations, but at the same time, she shouldn't be the one who's talking to the NRC about this. She was on the phone with the NRC. She would make an announcement to the site. There is one position that does do this that is absent from this movie, the emergency notification system communicator. There is one person on the crew, even a skeleton crew, whose sole role is to perform that function and to activate the E-plan. That person will activate the site's duty emergency response organization, a much larger team of nuclear engineers, maintenance personnel, radiation protection specialists, and a whole bunch of other people to get the shift the help they need. Also, our shift supervisor, when relieved by the emergency director, won't have to do both jobs anymore, so she'll be more free to manage the crew and how they respond to protect the core, and the emergency director will be directing all the emergency planning activities. So that is one of the first things that's great. As a former shift supervisor, it always feels good when you get some of that transition to the emergency director, so you can focus on the core, focus on your crew, focus on what really matters most. After all that, then you call that the ENS communicator calls the NRC. While the NRC does have a emergency response center, they're really just the regulator. They wouldn't be the person who actually helps you out because they don't know the plant specifically. They have a generic one for all sites in the country. In order to get that information, you need the site's emergency response facility, which does not exist in this movie. They got that way, way wrong. The NRC would mostly just ask questions, and then this communicator responds to the questions. That's not how you save the day by calling the NRC, and that's why the ENS communicator position exists. Also, everyone is standing around doing nothing when they should be checking the systems. It's crazy. And she said stage 1 alert. So stage 1 alert, that would be loss of on-site and off-site to one source. Loss of everything, that'll put you in stage 3, which is a site area emergency. And if it's expected to last for more than 4 hours, you can get to general emergency, which would lead to protective action recommendations, such as a site evacuation, an off-site evacuation of people that live in the surrounding areas, or shelter-in-place orders. And a lot of that depends on which direction the wind's blowing. So the important situation that she needs to know as the supervisor is how fast they can expect to get power back. Guessing they're showing this satellite communications thing because satellite uplinks were cutting edge for back in 2002. It's almost instantaneous communicating with your remote operations facility. You don't need to wait for a loading bar. They have systems in place that are already monitoring plant parameters.
I got my line.
Well, it looks like for this movie, the NRC is playing the part of remote emergency operating facility.
Go.
Going outside to try to get a signal on my cell. I didn't have a chance to before.
I should call him.
I am the shift supervisor, Neville, and it has to be me.
Nope. If she wants to title drop, she should just say emergency director, because again, that's her until she's relieved by someone else. And have the ENS communicator call. That is literally their job to do so. Again, her most fundamental priority as the shift supervisor, as the SRO, is to protect the core. That is why the NRC entrusted these people with these licenses, so they would do the right thing like that. Calling the NRC does not protect the core. Working through your emergency operating procedures to ensure the core is cooled, covered, and properly reactive does protect the core.
Want to shut down the electric coolant pumps?
They're redundant systems, Gail.
This is why you use procedures, guys. It tells you what systems to shed and what to save. Also, I thought they said they lost all power. If they still have coolant pumps, is the reactor still online at this point? I bet it is. Now I'm confused. They're not talking about the reactor at all, and okay, maybe they did just lose one source, and they really should just be in the stage 1 unusual event criteria. Okay, so things aren't nearly as bad as I thought they were, but you shouldn't have to worry about load shedding at the
Stage 1 alert means they have a problem. Call the NRC.
Well, that's not anything, is it?
Stage 2, evacuation personnel are put on standby. Stage 3, potential radiation leak. Total evacuation of the area.
Was there a stage 4?
Stage 4? Stage 4 means boom.
Wow. Remarkable, isn't it? The guy's right to say that there are 4 levels, but wrong about everything else. Evacuation or shelter-in-place recommendations, again, is stage 4. No alert by itself implies a radioactive release. Now, that's put on when you send out the emergency notifications. You have your duty radiation protection manager, again, who is absent in this movie. They're doing all the dose assessments using some software, and that goes out with the recommendation to the local authorities. You can have stage 4 general emergencies without any radiological release in progress. Also, no emergency is boom. That doesn't even make sense. If something exploded, then why even have an emergency? Because everyone's already dead. And no, a nuclear power plant emergency will not result in the entire Tennessee area being completely destroyed like they said. Even a direct hit with a nuclear weapon wouldn't result in that, let alone something that happens at a plant that will be confined to the area, because that's why reactor containment buildings exist. That's why we have all these advanced safety systems exist. That's why a robust reactor coolant system and the fuel cladding around each of the individual fuel pellets. That's why all of those things exist. No emergency level in the nuclear industry is boom. Come to think of it, no emergency level for anything is boom, because again, you wouldn't have an emergency response if everyone's already gone. Yeah, that was painful to me.
The instruments are down. Frozen.
Okay, have you started the procedure? Have you shut down all non-vital systems?
In the process. But we do not have control of some of the systems to shut them down.
Okay.
Okay, so partial power. So, alright, so in a realistic emergency plan, alright, so we lost primary and backup to one source, so we're still in stage 1, unusual event. And you would still have control of systems, because even the systems that lost power, because they're all DC power, the odds of something like that happening would be, it wouldn't happen with a tornado. A whole bunch of other things would have to go wrong for you to lose instrument power. Even if you didn't shed any loads, you're still good for a few hours on battery powered things. So that's a whole mess. But yeah, they wouldn't. So everything I said about stage 3 and stage 4, that's only if you lose everything. They're clearly not there. And if you have any of those other redundant trains, you're fine. Yes, you want to restore, but you don't need a load shed at all. If you haven't lost all power, then you don't need to do that. The whole purpose of load shedding is to maximize coping time when you're only on DC power. But if they still have a diesel working, they're fine. This is what a diesel looks like, by the way. It is a massive engine the size of a building. One of those is all you need to save everything. This isn't, these diesels that they were alluding to, they're not like this little household generator you get during a storm that can't run both the fridge and the microwave at the same time. These things are massive. They produce 5-6 megawatts a piece to run all the pumps, all the emergency equipment that you would ever need. And again, they have many of these on site. So partial power, your priority is not to load shed. Your priority isn't even to restore the power. Your priority is to make sure everything with the core is still okay, which it should be, and then have your emergency response maintenance crews go ahead and fix everything. Uh-oh, looks like they have a leak. But they probably won't notice it because they got distracted by this whole inane load shedding task and no one's actually watching the reactor. The tornadoes shouldn't have caused a leak. This leak must be the aligning of something else, as it's in a reactor containment building that can withstand the force, even a direct hit with a tornado.
Okay, 4A, last one.
I don't think it's anything. I think it's a cafeteria. Did you bring a flashlight?
Is there even one competent person at this plant? These two goobers, man. Yeah, I think they probably don't even know how to read that drawing. Again, they should have a proper procedure. If they're going to do load shedding, there's a procedure that tells you how to do it. And any plant operator has a hard hat light in addition to flashlights. These guys are just bad.
How's the reactor?
It's running a little hot.
A little hot?
Only 2 degrees.
Finally, someone asked about the reactor after, I don't know, a couple of hours of real time in movie. Yeah, 2 degrees hot. Now that really isn't cause for concern by itself, but again, you need to monitor it. Gail, I'm guessing she's the only closest thing they got to a primary reactor operator. That is her job. She shouldn't need to be prompted by her supervisor to call out reactor stuff. She probably even should have just made an update to the crew saying, hey, everything with the reactor's fine, or there's a bit of a trend of temperature trending up, but I'm gonna maybe raise steam dumping rate to compensate, things like that. Operator fundamentals, as we say in the industry. But bar graphs, no. She needs to have like trend lines and looking at also other indications than just the computer. Board indications actually respond a little faster, especially with this ancient 2002 computer. So use diverse indication, point out anything wrong with critical parameters, and anticipate that things are happening. So, it's like, okay, so we're down one source of power, so you can also talk through contingencies of what happens if we were to lose another one, because there's still tornadoes out there, for instance, and have a plan of how we're going to control temperature, and just brief about it with the supervisor and just get everyone on the crew on board for what we're doing. Just basic stuff. Evidently they haven't noticed the leak yet. You probably would at this point, but Not sure if these steps in a movie were shown out of order. That can always be.
We got our instruments back, but we're running hot along the coolant lines. The diesel pumps are damaged, and something's wrong with the electrical
I
pumps.
shut down the electrical pumps.
Why would you do that?
You said you wanted power. I gave you power.
Oh my god. So that implies that their instruments were AC powered and their backup systems did not have enough to even prevent their instruments. Okay, that is a baffling design that would not exist. Like they suddenly just got their instruments back. All right, so maybe this plant really does run on a cheap diesel that can't even run anything at once. Nothing like a modern nuclear plant. Nothing like any real nuclear plant. Now, even at Chernobyl, they had safety systems. They just decided to turn them off for a crazy test. Is this plant poorly designed, worse than Chernobyl? That's pretty bad. And as far as these guys turning off the spent fuel pool pumps, no operator would do that. It's silly. Now, part of it's on the shift supervisor that she should have been more specific in terms of shedding power. She said just, I need power back. It's like, okay. She should have said something like, turn off all balance of plant support systems because the turbine's offline now, or something like that. But she should have given a more specific order. But these guys, just basic fundamentals. Spent fuel pool is a critical system. Do not shut off cooling supply to it. Even if you have a backup, you still need to at least raise that question. And you'd never be in no load shedding procedure would have you do that. That's just not even a thing. There is a list of things that it tells you to do. So, man, this is just a poorly designed plant. And the operators are making this event even worse. Tune in next time on part 3 of Atomic Twister, where we see how much worse the situation can possibly get. Thank you very much for watching. I'll see you next time.